more of a process than adding and subtracting matrices. It's not as simple as just multiplying the corresponding elements. So it's important that as we go through this, you really do understand that process, or you will be totally lost. So the first part we are looking at is making sure you understand when you can multiply matrices. So it is possible that you will be given two matrices and you're not actually able to multiply them. So we'll first go through how you determine if you can multiply matrices. So it says at the top you can multiply two matrices A and B if and only if the number of columns in A is equal to the number of rows in B. So you can only multiply A and B if the number of columns in the first matrix A equal the number of rows in the second matrix B. So what the second sentence explains is actually down here, and I realize it's kind of faded, but I'm going to explain this diagram. So we have A and B that are being multiplied together to get A times B. If A has dimensions M by R, and remember dimensions are rows by columns, so A has M rows by R columns, and then matrix B, it's saying it has dimensions R by T, so R rows by T columns. To be able to multiply two matrices, the columns in the first matrix have to be the same as the rows in the second matrix. So these have to be the same. I'm just writing over what is already on the sheet, but I know it's faded. That's why I'm writing over it. So those have to be the same. If they are the same, then notice the dimensions of the product are M by T. So M rows and T columns. And that comes from the number of rows in your first matrix and the number of columns in your second. So the columns in the first and the rows in the second have to be the same to be able to multiply them. The dimensions of your product then are the rows in the first matrix by the columns in the second. Those give you the dimensions of your product. And it is helpful when you're multiplying to know what your dimensions are supposed to be in the end, because that can help you determine if you're multiplying them correctly, if you're getting the correct dimensions or not. So example 1 is not multiplying anything, just determining can you multiply them. So it says determine whether each matrix product is defined, and if so, state the dimensions of the product. So looking at example 1, we have matrix A and matrix B. And if we are multiplying these together, so we're trying to find A times B. A is 4 by 6, 4 rows, 6 columns. B is 6 by 2, 6 rows, 2 columns. With what we talked about above, would you say, yes, we're able to multiply these, or no, we're not? Yes. The columns in A match the rows in B. They're both 6. So these are the same. So I'll say, yes, AB is defined. And then I'm just going to write below this AB, and I'm going to list after it what the dimensions are. So also looking at what we said above, what would the dimensions of A times B be? Well, not 8. We listed as rows by columns, so I think I know how you're getting 8, though. 4 by 2, yes. So the dimensions would be 4 by 2, the number of rows in A, the number of columns in B, the 4 by 2. And again, this is just helpful. I mean, this question is actually looking for you to say what the dimensions are, but this is helpful to know when you're multiplying anyway, before you do it, to know if you're getting the right matrix in the end. So if we look at part B then, we have A is 3 by 2, 3 rows by 2 columns. B is also 3 by 2. So we're determining, does the product A times B, is that defined? Could we multiply these two together? I see some no's. The columns in A are 2. The rows in B are 3. These are not the same. So A times B is not defined. So with the practice, you will have some that you could be given, and it's just not possible to multiply them. But you have to know how to determine whether or not it is possible. Okay, any questions on that example, determining whether it's possible? Okay, and we'll just be talking about that too as we go through our examples. So now, to actually multiply them, like I said, it's important you understand the process. It says the product of two matrices is found by multiplying rows by columns. That's how I describe it, multiply rows by columns. And I include this diagram. This is not a formula that you should spend any time trying to memorize. This is just to help you understand how to multiply. Your two matrices will not always be these dimensions. So that's why trying to memorize this would be a waste of time. You have to understand the process. So I am going to use this, though, to explain the process before we look at example 2. And rather than read through this with you, I'm just going to show you what it's trying to say. So if you think in your mind, I'm multiplying rows by columns. You start out by taking the first row in the first matrix. So I'm just going to label this row 1. And then I'm multiplying that row by the first column in the second matrix. So multiplying rows by columns. So this would be column 1. And when I multiply that row by that column, the value I get, and I'll explain how to get the value, goes in row 1, column 1 of your answer. So when you multiply row 1 by column 1, that goes in row 1, column 1. And then how these are multiplied is you take the first element in the first row in that first column, so A and E, you multiply A times E, and that shows that here, and then you add the product of the second element, B times G. So it'd be A times E plus B times G. If there was another element in the row and the column, you'd say plus, and you'd multiply those together. So you'd keep going until you have however many products you need added together, but that's one element. And then what you would do then is you'd still take your row 1, and then you'd multiply it by column 2, and that product would go in row 1, column 2. Okay, so rows by columns. So I don't want, I'm trying to make the highlighting somewhat helpful, but I don't also want to confuse you more. So I'm going to skip ahead and look at example 2 so you can just see how to work through this. We're going to go through a couple of these together. So example 2, and I know these matrices are the same dimensions as up here, but try not to even look at this in terms of using a formula. I don't want you to think I have to memorize the formula. You have to know the process. So if I'm finding U times V, given the matrices U and V. So I'm just going to write down matrix U, just so I have these side by side, and then matrix V. And first, what are the dimensions of matrix U? How many rows, how many columns? 2 by 2. 2 rows, 2 columns. Okay, matrix V is also 2 by 2. It's the same size. So this is what you should check before you even start is, can you multiply them? As long as the columns in the first matrix and the rows in the second matrix are the same number, then you can. What are the dimensions of our product U times V going to be? My answer is going to be what dimensions? This is what we had determined up above as well. Caitlin? Thank you. Okay, so it should be 2 by 2 in the end, the number of rows in the first by the number of columns in the second. Okay, that's going to be helpful for you to know for your answers. So I know I should be ending with a 2 by 2 matrix. All right, so as I multiply these, I'm going to multiply, I start out with the first row, and I multiply it by the first column. All right, and I multiply the first elements together. So the first element in the row is 5, the first element in the column is 2, and then I multiply the second elements together and I add them. So I would have 5 times 2. I'm actually going to write this full thing out for this first example so you see where everything is coming from. So I have 5 times 2 plus 9 times 6. And that whole expression goes in row 1, column 1 of my answer. Then I stick with row 1, and now I multiply row 1 by column 2. So row 1 by column 2. And again, I multiply the first elements together, the second elements together, add them together. So I have 5 times negative 1 plus 9 times negative 5. And when I multiply row 1 by column 2, that goes in row 1, column 2 of my answer. So that is going to simplify to just one number. And once you've multiplied row 1 by all of your columns, you're done with row 1. So if it's helpful to you, just so you know I don't have to use it anymore, you can cross it out. I multiplied that by every column, so I'm done with row 1. And that means my row 1 in my answer is also complete. Now I'm in row 2. So I do that same process now with row 2 and column 1. So row 2, column 1. So the first elements I multiply together, negative 3 times 2, plus the second elements, negative 2 times 6. And when I multiply row 2 by column 1, that goes in row 2, column 1 of my answer. And then I have row 2 by column 2, last one, and that's going to go in row 2, column 2 of my answer. Multiply the first elements, negative 3 times negative 1, plus negative 2 times negative 5. And once I've multiplied row 2 by every column, I'm done with row 2. So now if I had another row, I would just keep adding on. But even though I do need to simplify this, I said in the end I should get a 2 by 2 matrix, and this is 2 by 2. I have 2 rows and I have 2 columns. So that's why knowing the dimensions ahead of time can be helpful. Are there any questions before we simplify this, just on where any of this came from? All right, so then in simplifying, I just figure out what these four values are. So for the first one, 5 times 2 is 10, plus 9 times 6 is 54. So that would be 64. Still in the first row, second column, I have negative 5 plus negative 45, so that's negative 50. And then in the second row, first column, negative 6 plus negative 12 is negative 18. And in the second row, second column, positive 3 plus positive 10 would be 13. And this 2 by 2 matrix is the product U times V. Okay, questions on example 2? Okay. So we're going to go through example 3 together as well, or part of example 3 together. Example 3 is giving you two matrices K and L, and part A wants us to find K times L. Part B is L times K. So part of this too is you're going, bless you, you're going to determine if K times L and L times K are the same. Because we know with numbers, for example, if I multiply 3 times 5 and then 5 times 3, that's the same. You're going to see, is that true with matrices? Does the order you multiply them in matter? Is going to be the question. So, while also practicing multiplication. So with K times L, I'm going to copy down matrix K first. And then multiplying that by matrix L. And first you want to determine, can you multiply them before you start? What are the dimensions of K? 2 rows, 3 columns, 2 by 3. And then what about L? Has 3 rows and 2 columns, so can we multiply them? Yes. K has 3 columns, L has 3 rows. They match. What are the dimensions of K times L going to be? The end will be 2 by 2. So completely different dimensions from the 2 we started with. But again, it's helpful to know. That way, if you end with a 2 by 2, you know that that's what you're supposed to end with. So for this one, I'm not going to show exactly all the work I showed in the last one, but I'll still show some work. The amount of work you actually show ultimately is up to you. I encourage you to show at least some work, because if your answer is just wrong and I can't determine then where your mistake was made, there's no chance for partial credit there. I don't know how you got your answer. So again, I start out, I'm not going to do as much highlighting with this one, but I'm going to start us out. I multiply the first row by the first column. That's where you start. Rows by columns. And notice too, this is why the number of columns in the first one and the number of rows in the second matrix have to be the same, because your row and your column have to have the same number of elements. Notice they both have 3, and that's because those columns and rows are the same. So here I have to multiply the first elements together, so negative 3 times 1 is negative 3, plus the second element's 2 times 4 is 8, plus the third element's 2 times 0 is 0. So I multiplied row 1 by column 1. That whole thing is one element. It goes in row 1, column 1. Now I do the same thing with row 1 and column 2. So I multiply the first element, negative 3 times negative 2, that's positive 6, plus the second element, 2 times 3, that's 6 as well, plus the last element, 2 times negative 1, that's negative 2. And that row 1 times column 2 goes in row 1, column 2. And now my first row is done. I multiplied row 1 by every column, so I don't need that anymore. I do now the same thing with row 2. So I multiply row 2 by column 1. First elements are -1 and 1, so -1 times 1 is -1, plus -2 times 4 is -8, plus 0 times 0 is 0. And then I have row 2 times column 2, and that'll be my last element. So the first element's -1 times -2, that's +2, plus -2 times 3 is -6, plus 0 times -1 is 0. And then to finish this, I just simplify each of those 4 elements. So in row 1, column 1, I have -3 plus 8 plus 0, that's 5. Row 1, column 2, 6 plus 6 is 12, plus -2 is 10. And then in row 2, column 1, -1 plus -8 plus 0 is -9. And then in the last element, 2 plus -6 is -4, plus 0 is still -4. So this would be K times L. Okay, questions on part A of example 3. Okay, I'm going to leave this up here, but I want you in your groups to find the product L times K. I would recommend actually write down the matrices, write L first, followed by K, so that you can kind of work in order, remember rows by columns. But find that product and then compare, is it the same as K times L? Does the order you multiply matter? For this one, I am going to walk around. I do want to check that everybody is able to get the right answer. So if you finished and I've checked that you have it, you can start working on the assignment right away. I do really want to make sure with this one everybody's able to do it, because understanding this process is important. From here on out, anytime we multiply matrices, I want to make sure you all know how to do it.